So this is a concave mirror pointing toward that. Let's say I'm going to use a scale here. Let's say the focal point is 5 units away. 1, 2, 3, 4, 5. This is where the focal point is. 1, 2, 3, 4, 5. This is where the radius from here to there, which is really the center of the sphere. If you were to put the sphere, the center, that's where the center is. And the question is, if I give you an object, let's say I put an object here. And the object could be anything. I'm going to use a candle here. This is my candle. That's like my candle. Notice it's like 3 units tall. This is my object. Where is the image of that going to show up? I put it to the left of C intentionally. Notice to the left right there. Where is that image going to appear? So we're going to do 3 lines. I'm going to actually use color code for them. Here we go. The first one, we'll call it the P ray. Why they call the P? P for parallel. Start from the object. From the object. Usually I go to the top of the object. I do more from the top of the object. Parallel, you can draw a line that's parallel to the axes. So draw a line from the top parallel to the axes. That's this one. That's the P ray. From top of the object, oh, P, I wrote R here. P. Draw a line from top of the object parallel to the axes. We did that. Then this line is going to hit the mirror, is going to reflect. Reflects through the focal point. So let's reflect this through the focal point. The reflection of this beam is going to go through the focal point. So that's the P ray. Done with it. The next one, I'll use a different color. I'll use red. The F ray. Why they call it the F ray? Because it goes through the focal point. So start from the object. Just to stay with the notation of our book here, just make sure. The F ray. Start from the object. Top of the object. I do more from the top of the object. Through the focal point. So that's the F ray. Start from the top of the object through the focal point. Let's keep going. Here we go. This is the F ray. It's going to hit the mirror. It's going to reflect. Now let's see what the reflection. Then reflects parallel to the axes. So it's going to be parallel to the axis. It's going to come out this direction. I can tell you right now where the image is going to be. Right where the two lines intersect. But I'll do one more. There's a third one. So we use blue, we use red, we'll do black. The next one should be called the C ray. You're going to start from the top again. Through the center. Through the center. Well, if going from the center to an object, remember this coming from a sphere. Any line that goes from the center to the sphere is going to make a 90-degree angle. It's going to be a normal line. Oh. So this really makes a 90-degree with the mirror, but I made the mirror looks like straight, but it's not. You know it's curvature, but I try to pretend it's a straight line. That's the C ray. Since that hits the mirror at 90 degree, that's this ray right here. This beam going through the center, hitting that mirror, bounces back, reflects back through the same point. Then reflect back through the center. So reflect back through the center, it goes in that direction, then reflects back. Where the three reflections meet, that's where your image is going to be. So your image is going to be right here. That's where the three beams, notice, meet right here. That is my image now. And that dot that you see where they meet is actually the tip of that candle. So this is my image right here. Right there. What do you notice about that image in terms of size first? The image. What do you notice about the image?
Smaller.
Smaller, so reduced, right? What else you notice about them? The image. Isn't it upside down? Inverted. What else? It's on the same side. Same side as the object. We'll talk about these later. Same side as the object. Now let's change that just a little bit. Let's put the object between C and F and see what will happen. Let's put it inside F and see what will happen. Let's look at the convex mirror and see what will happen. So let's take between C and F. Let's do another one. Now we'll do the object between C and F. We'll do the same scale. Let's draw axes here. I'm going to make my mirror straight line up and down instead of curvature in it. So this is my concave mirror. I'll put a few lines in the back to let you know I'm using this side, the shiny side on this end. 1, 2, 3, 4, 5. That's F. 1, 2, 3, 4, 5. That's C. And let's put the object anywhere between F and C. I don't really care where you put it. So here's the object. I'm making it tall too. That's my object. I'll try to stick with the color coding. The P-ray, the parallel, I use blue for that. In case you forgot, the P-ray goes through this one, parallel, and that's the P-ray, and it comes out through the focal point, right? That's a deflection of it, or a reflection of it. The correct word really reflection, not deflection. Deflection, that means you continue going straight, but you bend. This one reflects. The F-ray, I use red for that. That goes through the focal point. And when it hits the mirror, it comes out which way? Parallel, right? That's the F-ray. Again, where the two of them meet, it's where your image is going to be. I'll make this longer. And the third one is the C-ray. I'm in trouble, I made the object too long here. I probably will never hit it here. See, the C-ray is going from the center. It looks like it's coming from the center. It's going from the center, but since the center behind me here, it will be in that direction, going in till it hits the mirror. And once it hits the mirror, what happens? It bounces back, reflects back. So going through that, it hits the mirror, then it bounces straight back. And where the three of them meet, again, which you can see it now, that's your image. This is the image. What do you notice about this image? It's larger, right? What else? It's inverted. And what else we notice about it? Same side. When I say same side as object, what do I mean by that? The object is on the left side of the mirror, the image on the left side of the mirror. Can the image be on the right side of the mirror? Yes. You'll see that in the next example. God. We're going to be talking about something called magnification, M, which is how much larger is the image or how much smaller. Well, the magnification is the ratio of the height of the image to the height of the object. High over low. Height of the image over height of the object. Well, what is the height of the image? How many boxes the image is covering? 1, 2, 3, 4, 5, 6, 7, 8, 9. A little bit more than 9. Maybe 9 1/4, 9 1/3. And how many boxes does the image cover? I mean the object. 1, 2, 3, 4. The height of the object is 4. Notice my magnification, it's more than 2 here. The image is more than twice the size of the object. And will be a negative. Why? Because it's upside down. So when we talk about magnification, we're going to say the magnification is minus. The minus tells me it's upside down with numbers when we start doing the math shortly. So that's 9.3 divided by 4, roughly negative 2.325. The negative again tell me it's inverted, and since this number is more than 1, it means larger. So when we do the math and you get a magnification of a negative number, negative 4, that means upside down, and it's 4 times larger. If the magnification minus 0.2, it's upside down, and it's smaller. It's 0.2 of the actual size. Let's look at the third case. If you put the object between F and the mirror, what will happen? F and the mirror. Again, all cases so far I'm doing concave mirror. I didn't do convex yet. This is my mirror. Again, concave mirror. And 1, 2, 3, 4, 5, F. 1, 2, 3, 4, 5, C. Now put the object here. I'm going to make the object big a little bit there. Color coding again, I forgot. The P ray is the blue, parallel. Parallel. Notice this is the blue, the parallel. Is going to come out through the focal point. The F ray, red I use for that. That's through the focal point, coming out from the focal point through the object. So this is the focal point. It looks like it's coming from here. And when it hits the mirror, it comes out which way? Reflects parallel. Parallel is going to be that way. This is the F ray. And the last one is the C ray. Coming from the center to the object. And deflects back through the center. So these are the three rays. And notice there's no way they're going to meet on this side. There's nothing. They're going away from each other. The three lines have to meet where the image is going to be. So to find out where the image is going to be, you need to extend the lines. Let's extend each one of these lines. That's this line. Let's take the red one, extend the red one. That's the extension of the red one. And let's see what the extension of the blue one is. And all three of them meet where? Right here. So that's where your image is going to be. And what do you notice about the image? One thing I notice is in the upright, right? It's not inverted. What else? I notice it's larger, right? What else? On the other side of object. The object is on the left side of the mirror, the image on the right side of the mirror. Some of you probably, especially the ladies, you might have at home in your bathroom, one of those round mirror, big mirror, and when you bring them close, your face becomes about this big. If you put makeup on or you're trying to pluck your eyebrows and everything, you look closer, it works on that principle. The lens is bent like this, it's concave. The mirror is concave, not a lens. The mirror is concave. The focal point is behind your head, so when you put your face close to that, you're putting your face actually between the focal point and the mirror, which will make the image much, much bigger. Notice in this case, the magnification, how many times bigger? The magnification here, let's count how high the image. 1, 2, 3, 4, 5, 6, 7, 8, 9, almost 9, divided by 1, 2, 3, 4, by 4, you get 2.25. So you're making it more than twice the size. It's easy to see, to put makeup on, pluck your eyebrows, whatever you're trying to do there. We'll talk about the same side and opposite side, what that means, in a few minutes, because that will tell me if the image is real or virtual image. So these are all the three options, unless you put them at the focal or the C, but the three choices for the object, usually between F and the mirror, between F and C, and beyond C, for concave. For convex mirror, all these are concave mirror. For convex mirror, it doesn't matter where you put the object, it does not change anything, it's always going to be the same scenario. So there's only one example to draw there. Let's look at that. Let's look at convex mirror. So now we're going to do a convex mirror instead of concave. And convex, it's like this. The curvature is out to the inside. So this is using the outside of that globe there. You're looking at a globe there from the outside. So the outside is round like a basketball. You're looking at a basketball there. That's a convex mirror. 1, 2, 3, 4, 5. It doesn't have to be 5. I'm just using a scale of 5 here. 1, 2, 3, 4, 5. And you put an object there. It really doesn't matter where the object is placed. The mirror actually has another 1, 2, 3, 4, 5. That's where the focal point on this end. And 1, 2, 3, 4, 5. That's where the center on that end for that mirror. So it's not really the focal on the center is not on this end, because the center, that comes from a sphere. And if you continue with the sphere, like this, so the center is here and the focal is there. I shouldn't even ever put them here. But I'll do this. Actually, I'll take them out of this side. Your focal point on that end, not on this end. This comes part of a sphere. We cut a little piece of it. There's the center of the sphere. This is the focal point, halfway through that. Put an object anywhere here. It doesn't matter where. I'm going to make the object bigger because the image is always going to be smaller here. So I want to be able to see it. So this is my object. And color coding again. Blue is the P ray, the parallel. And here's what's going to happen. It's supposed to reflect through the focal point. It's not going to go through that mirror. That mirror is painted on the back side of it. So it doesn't come through the mirror. It's going to look like it's coming from here. It's going to deflect or reflect that way. like it's coming from the focal point. That's the reflection. It looks like it's coming from that point. For convex. The P ray. Now the focal point, I use red, the F ray now, going through the focal point. This is the F ray. So if I continue with that, it looks like it's going toward the focal point. As I said, it's not going to go through that point. This is the F ray. Once it hits the mirror, it's going to reflect parallel to the axes. Parallel, it's in this direction. It's going toward the focal point. Once it hits that mirror, it changes mind and it goes backward parallel. And the third one's the C ray, going through that center. Here's the center. That's the here we go. Going through the center. And just like if it can go through it, we'll go through it like this, but it can't go through it. When it hits the center, it deflects back and it goes backward. And notice again the three reflections, this way, that way, and this one. And where is the image going to be? Let's extend all the deflections and let's see what will happen. If you extend the three deflections, this is one of them. I should use a different color. I don't have a different, let me see. Maybe I can find something I can use. I got it. We don't need a thick one. This thick blue one. If I extend all the deflections or reflection, let's extend this line. Let's extend this one. And let's extend this one. And where the three of them meets, that's where your image is going to be. That's your image. And what do you notice about that image? It's in the upright, right? Other side. And what? Reduced, smaller? That's where the image is going to be. Now, if the image shows up on the same side as the object, if the image, I'm going to write this, is on the same side as the object, we call that real image. And if the image shows up on the other side, of the object, We call that virtual image. So when you do your math, when we start doing this mathematically, I here will be positive. That's how you know if it's real image or virtual image. The value for I will be positive. When we do it, if it's virtual image, I will be negative. In a few minutes, we're going to do this without graphing them. So, before I get to the equation, let's summarize the three cases that we have. I'm going to summarize them. I'll do the concave. So you'll have one sheet with you with all the pieces on it. Just this is for concave only. I'm going to summarize the three cases on one graph because that comes in handy when we start doing complicated problems. Concave, we said the mirror looks like this. It's bent in. This is F. This is C. Let's put a dotted line here and a dotted line here. If the object to the left of C, let's go back here to my picture. If the object to the left of C, where was that? That was here. The object was to the left of C. What do we notice? The image is what? Shrunk, can you see that? Reduced, inverted, the same side as the object. Same side means what? Real image. So summary, you're going to have a real image right there on the same side, inverted, right? And what else we said? Isn't it reduced? Shrunk? Right there. We went through that, we drew them, and that's the image. Inverted, reduced, real object. Real image. Now, case number 2. We put the object between C and F. What was the story with the image? Larger, inverted, real. So here, if you put the object here, we have real image. Inverted. And enlarged. Bigger. And case number 3, that's this one. If you put the object between F and C, upright, that means not inverted, larger, and on the other side, which means what? Virtual image. Virtual image. It's not inverted because that upright. And we said what? Enlarged, larger. So these are the 3 cases for concave mirror. And for convex, we only had 1 case. Maybe I can put them on this page. This is concave. Maybe I'll put convex right here. Just erase this. For convex, so I don't have to look at one page. Convex, the mirror looks like this. And it doesn't matter where you put the object is, it's always going to be the same. I have these cases, where are they? Right here. It's upright. Reduced. And it's on what? The other side, that means what? Virtual image. So if you graph them, there's your all scenarios. Unless you put it on F and C. That's the only other option. If you put the object directly here or directly here. But that's all the possibilities you're going to have. Now, instead of doing, actually on the test, I'll ask you to graph them, and I'll ask you to do them also with the equation. Instead of graphing them, people say, I don't want to graph them and use all this color code and go through it. Is there an equation I can use that will get me there? And the answer is yes. And I can make that a separate, probably, topic here. I'll continue with that on the same slide, video. How about the mirror equation? Excuse me. We have an equation we're going to be using, and it says we can go through the math and derive it and go all gung-ho with it, or I can just use it. And the mirror equation goes 1 over distance of the object plus 1 over distance of the image is equal to 1 over f, the focal point. Me personally, I write that 1 over O plus 1 over I equals 1 over f. O is the object, I is the image, f is the focal point. Now, before we get to that, let's write a few things. F, the focal length. Now, F is positive for concave mirrors. The book doesn't tell you positive or negative. You have to know. And F is negative for convex. That's the focal length. The magnification is the height of the image over the height of the object. I forgot to write that. The height of the image, I did it earlier, but I didn't write it here. The height of the image over the height of the object. It can also you'll see actually our book will use a minus sign with that. It's minus the height of the image over the height of the object when we get to it. Magnification is also happens to be negative the distance of the image over the distance of the object. This is positive, this is negative. It's the ratio of the two heights. Now let's talk about the magnifications. M. M is positive. If it's negative, that means it flipped upside down. For upright, when the image is in the same direction. Upright image. M is negative for what? Inverted images. This is just about the sign, positive and negative. I, which is the image distance. When you do the math, the result is either going to be positive or negative. What happens if it's positive? I is positive. For real image. That means on the same side. Same side as object. I is negative for virtual images. Virtual images means other side of the object. Other side. And the object, the last one, O for object. Object distance. How can the object be negative? We're going to talk about positive and negative. How can an object be negative? Well, a lot of times you walk into an elevator and there's a mirror on this side, a mirror on that side. You walk in, how many of yourself you see there? Infinite. Because that picture now, your face, you'll have an image there. That image becomes an object for another mirror. That image now becomes an object for this mirror, and back and forth. So when you have more than one mirror there, you could have a real image or a real object or a virtual object. So O is positive for real object. What does real object means? That means the object in front of the mirror. In front of the mirror. Or O is negative for virtual object. That means behind the mirror. Again, when you walk into a store to buy a dress, they have these mirrors surrounded by mirrors. You put the dress on, you look at yourself, you see the front, the back, and everything. Well, the reason you're seeing the back, because your image now becomes an object through another mirror, so you get to see it. So if that image in front of the mirror, it's a real image. If it's behind the mirror, it's called virtual object. So we're going to use this information when we use that equation. So let's see how we're going to use that equation. Let's take an example and go through it. So now you know which one's positive, which one's negative, and where they are. Let's assume, as an example, let me find one here. A concave mirror, ready? A concave mirror has a radius r equals 30 centimeters. If an object is placed let's do it twice. The first time at 45 centimeters and the second time at 10 centimeters from the mirror. The question is, where is the image? Formed. And you know, while we're at it, that's not enough. Where's the image formed? And tell me more about that image. Comma. And what are its characteristics? Excuse me. Is it real image? Is it virtual image? Is it inverted? Is it bigger? Is it smaller? Without a graph in it. Let's do part A. We know the distance of the object is what? 45 centimeters. We know the focal point. The focal is 1/2 r. It's positive because concave. That's 15 centimeters. Can I figure what I is? This is part A. I'll do part B right there. 1 over I plus 1 over O equals 1 over F. 1 over I plus 1 over 45 equals 1 over 15. 1 over I equals what? 1 over 15 minus 1 over 45. And I came up with 0.044. What is I equal to? 1 over that number. Is 22.5. Notice it's a positive value. There's a positive here. I know that's a real image. So it's placed 22.5 centimeters to the left of mirror. That's why it's real. To the left. It says, where's the image? 22.5 centimeters to the left of the mirror. Is it bigger? Is it smaller? What's the story with it? Well, let's look at the magnification. It's negative I over O. Negative I is what? 22.5. O is what? 45. Is that negative 0.5? The negative tells me what? Inverted. And the 0.5 tells me it's what? Reduced to half the size. So I'm telling you everything about the image. The image is real image. It's on the left side of the mirror. It's 22.5 centimeters to the left of it. It is upside down. It's shrunk to half the size without having to graph it. Now part B, what will happen if the image is 10 centimeters? So, the object. The object now is 10 centimeters. The image is 15. And let's do the math. 1 over I plus 1 over, the focal point, not the image, is 15. I'm looking for the image. One over I plus 1 over 10 equals 1 over 15. 115 minus 110. It's going to be a negative. Negative 0.033. I is going to be negative 1 over that number. Negative 30. Negative tells me what? It is a virtual image. What does that mean, virtual image? On the other side, the image is 30 centimeters to the right. If I put the object on the left, to the right of the mirror. If the object on the left. What's the magnification? Negative I over O. Negative and negative, that's positive 30 divided by O, which is 10. That's a plus 3. Plus means what? In the upright. And the 3 means what? Larger. Enlarge. 3 times bigger. Larger. So I can tell you everything about the object and the image. I'll do one more example on that. When you go to the dentist, you've probably seen the dental hygienist or the dentist. They have this little mirror on a little thin rod they put through your mouth to see what's going on. So we're going to use that. Use an example on that. You go to the dentist, they stick that mirror in your mouth. We have no idea if it's concave or convex. But here's what we know. A tooth actually that they're looking at is 1.2 centimeters tall or long in front of the mirror. The image is 9.25 centimeters behind the mirror. Find the focal length of the mirror and the magnification. Find A, the focal length, which is f, and B, find the magnification m. let's see what we know from the problem. The object is placed 1.2 centimeters in front of the mirror. That's a real object. 1.20 centimeters. The image I, notice you gotta be careful here, is 9.25 centimeters behind the mirror. So what's the image equal to? Is that a real image or a virtual image? So it's a negative. They don't tell you that, so you have to know that. Behind the mirror. That's a virtual image. So I can answer question number 2 now, B. I can answer number 1. I can answer them both. 1 over I plus 1 over O equals 1 over F. 1 over negative 9.25 plus 1 over 1.20 equals 1 over F. One divided by negative 9.25 plus 1 divided by 1.20. That's 0.725. What is F equal to? 1 over that number. It's 1.37. Is that a positive value or a negative value? Positive. That tells me what kind of a mirror they're using. It's a concave mirror, not a convex. Concave. What's the magnifications? Negative I over O. I is minus, so it becomes a plus 9.25 divided by 1.20. The magnification it's almost 7.7 times larger. Notice it's a plus. That tells me the tooth, when they look at the tooth, is what? It's in the upright, so it's not going to be upside down. And it's 7.7 times larger. It's almost 8 times bigger. So you can see everything on that tooth, that little tiny mirror that you look through. Are we good with this?
Z,
Yes.
I had a question from yesterday before we go on break, if you could do one of the problems.
After.
Okay. So for the homework, we don't have to graph?
Well, they'll ask you to do some with the graph, some without the graph.
Like graph on the computer?
Probably. I don't know how you graph on the computer. I'm not sure. You know, I'm sure they do something with the graph, and they probably ask you which one is the ray, P ray, or something. But I don't know how they'll make you graph on the computer. To be honest with you, I don't look at it. It could be, but I'm not sure. Let's try one more. One more example of this. Then we'll stop the video with this, take a short break, and come back and do more. An object 3 centimeters high. That's the height of it. Is placed 20 centimeter from a convex mirror. Convex. With the focal length of 8 centimeters. Find A, the image, and B, the magnifications. Let's write by listing what we know. An object is placed where? 20 centimeters from the mirror, in front of the mirror. So that's the object is a real object, 20 centimeters. What else do we know? What's the focal? What's the focal length for the mirror? Do we know that? Try again. Try again. -8. Notice that I didn't tell you that. Where's my summary sheet? Focal length is negative for a convex mirror, positive for a concave mirror. So that's how they'll get you. F is -8. We're looking for the image. One over I equals 1 over -8 minus 1 over 20. It will be a negative number. Oh, forgot to turn on. Negative 0.175. What is I equal to? 5.7 with a negative. Again, the negative sign tells me that's what? Virtual image. What does virtual means? It's going to be 5.71 centimeter on the other side, or from the other, on the other side of mirror. If the object on the left, the image on the right. If the object on the right, the image on the left. The magnification, it's negative I over O. Negative. What's I? I is negative, that becomes a plus 5.71 over 20. 5.71 divided by 20, 0.29 roughly. Notice it's positive, so the magnification is positive 0.29. Positive means what? It's in the upright. And the size of it, 0.29 of the actual size. Shrunk, reduced. So if you want to find the height of the image, if I'm interested in that, how high is the image? How tall that image? Well, I know the magnification is the height of the image over the height of the object. The magnification is 0.29. Height of the image I'm looking for, the object is what, 3 centimeters? How tall is the image, or how high is the image? Times 3, 0.86. So that 3 centimeter high object will have an image of 0.86. An image of 0.86 centimeter high, little tiny one.